Okay, let's go ahead and talk about how to write up the post-lab for this acid-base titration lab. This one's kind of strange. So I'm going to try and navigate you through the write-up on this one as best as I can. So basically, we've already talked about how to write up the pre-lab. The beginning question, obviously, is just the beginning question. Okay. Background information, I think what I said to do on that one is use the explanation to strengthen student understanding to give a little bit of a introductory paragraph there, and then I said to answer the pre-lab questions, which are right here. And basically these pre-lab questions are the questions that you guys ended up, at least some of them, you ended up using your lab to try and answer. But I want you to give me some sort of initial idea of the answer to those questions before, well, I mean, at this point, if you haven't done it, you would be going back and doing it. But you only answered one of these questions in your lab group. So the rest of them, I just want to give you, even yours, but then the rest of them as well. I want you to give me just sort of some idea of what you think maybe the answer to those questions are. You're not going to be graded based on correctness for those because they're just to get you thinking about these particular subjects. So then, on the procedure itself, I think a couple of things here, and I think we talked about this already. There's the practice procedure, and that's right here, the practice of the instrumentation and procedure. And that, basically you just needed to have a data table and a graph for that section, because and the data table was the one that I gave you in class, and basically I think most of you just did a strong acid, strong base titration with sodium hydroxide and hydrochloric for the practice. We had that issue where the sodium hydroxide was a I'm sorry, that was the day after. So anyway, that one should have been fine. You should have been able to get your data on that one, get a graph for yourself, hopefully. If not, if you just weren't able to get your group data that day, that first day for the practice, what you could do, and I would be okay with this, if you go back to the pre-lab and look at the simulation that they give you here, this simulation, the Part 2 simulation here, if you go to that website, it will actually allow you to do a strong acid, strong base titration, and you could just do a practice one there and use the data that you get there to make a graph. So if you want to do that, that's fine. I found that website to be less helpful than I was hoping it would have been, but it could bail you out maybe if you had some trouble with that practice procedure. Okay, so I want that on there. The main thing that I want for your procedure is the actual investigation procedure, the one where you're trying to answer your particular question. So I suppose if you wrote your question that was assigned to you as your beginning question, that would be fine too. You don't have to do that. Just somewhere in your procedure, make sure that you tell me which of the questions you are answering so that I know. Okay? That procedure you should have already had written, most likely. It's just based on whichever question I assigned to you. And I know that we ended up, I think most of you got through 3 titrations, not 4. And I told you to just basically focus on answering your question. Make sure your question got answered. Okay? So hopefully you were able to do that with your procedure. Make sure that you put a safety section in there. And actually, I think there is a safety section in the lab itself somewhere. I can't remember exactly where it is here. There we go, safety and disposal. So that would definitely help you out with that section. Your observations and measurements, you needed to, again, record your data and make graphs for all the titrations that you do, which I know that part's a bit of a pain. That's going to be a little bit of a write-up there. I think most of you got through 3 titrations, so you would be doing, 3 data tables, 3 graphs in your lab notebook for that part. Now, the the tricky part here is this little section right here. Okay? So it says 2 of the 4 samples given to your group, to the group will have their molarity identified and 2 will not, which is kind of what they set up here. You use, an acid with a known molarity, an acid with an unknown, a base with a known, and a base with an unknown. And you guys were able to pick those based on your question that you were given. It says after collecting your data, make a titration graph, which we just talked about. All major points should be identified on the curves. So on your graph, basically when you have a titration curve, it's gonna, if you're titrating an acid with a base, it's gonna look something like that. Okay, depending on whether you have a weak acid or a strong acid, the curve may be steeper, the pH may start lower. It just depends. But the points I want you to label on your graph, definitely label your equivalence point. Okay, and your equivalence point would be kind of in the middle of your steep curve. So that was not a great circle, but in the middle of your steep curve is where you want, where your equivalence point would be. Okay, I want you to measure the beginning point of the titration. Obviously right here. Okay, I want you to label your. I said measure. I want you to label your last point of your titration. Those are easy, and then I want you to label also the point in the titration. If you're titrating with a weak acid, strong base, or a weak base, strong acid. Okay, for strong acid, strong base, you don't have to do this, but there's a point in the middle for a weak acid, strong base titration, like I have here, or if you're doing it the opposite way, a weak base, strong acid titration. There's a point right here in the middle between the beginning and the equivalence point, where you have a perfect buffer solution, an ideal buffer solution, because then you have equal amounts of the acid and its conjugate base. Okay, and so I want you to label that point. Okay, it says if a sample includes a weak acid and or base, percent ionization needs to be calculated, Ka and or Kb needs to be calculated, and the percent error of the calculated Ka to Kb or Kb to the accepted value should be calculated. So I want you to put this in your observations/measurements. Well, you know what? No, sorry. This part right here. The graphs, I want you to put in your observation measurement section, obviously. Okay, and then the labels on the graphs, that will be in the observation measurement section. As soon as you get right here to the percent ionization needs to be calculated, and the percent error, all of that stuff, I want you to put that in your claim and evidence section. Okay, so your claim evidence section. See, it's tricky to get this to fit into my format, so I'm sorry that this is so complicated. But as long as you follow along with the video, you should be okay. So your claim evidence section, you're going to calculate the percent ionization. Okay, now you might have no idea how to do that. Okay, it's not all that difficult. What you need to figure out is at the equivalence point on your graph, okay, this point right in the middle of your steep curve, you need to measure the pH based on your graph, the pH at that equivalence point. Okay, and then remember what the pH is actually telling you. Okay, so let's say we're doing a weak acid titration here. Okay, so the pH on that weak acid titration is telling you the concentration of the H plus or the H3O plus in the solution. Okay, so at that point, at the equivalence point, that's how much H plus or H3O plus you have in the solution. Okay. No, I'm sorry. Thinking about this wrong. Let me back up here. If you want to know the Ka or Kb of your weak acid or base, you need to start actually with the beginning. Okay? So basically all you have to do there is look at the pH that you started with. Okay? And that's either if you have a weak acid, okay, that's going to be your pH right there. Okay? And if you have a weak base, obviously it's going to be right up here at the at the beginning of this one. Okay, so you should have measured your pH at the very beginning, obviously. That would be your very first number before you add any strong acid or strong base into your titration. The way to figure out your Ka there, or your Kb, figuring out your percent ionization, you're just going to basically set it up. So let's say, for example, you used acetic acid, so C2H3O2, which I think they list as C2H, I can't remember exactly how they do it, something like COOH at the end, I think. I always forget that way of writing it. CH3COOH, I think, is the way they list it in the lab, which is basically the same thing. Okay, and so then your equilibrium here would be, it's giving off an H plus, and then it's forming C2H3O2 minus acetate. Okay, and then you've got your ice table. So then the way you figure this out, you're going to figure out basically what your starting concentration of your acetate was, or acetic acid. So if you started with a 0.1 molar solution, which I think is what our molarity was to start out with, and then you're going to just assume you have 0 of both of these, okay? And then at equilibrium, you've measured the pH. This right here, the weak acid at the very beginning, when you're measuring the pH, we're going to assume that's at equilibrium, okay? So at that point, you're basically measuring what is the H plus concentration, okay? Because pH is the negative log of the H plus concentration. So use the pH to figure out your H plus, and that's the number that you're going to put right here, okay, in the equilibrium blank. Alright, so then you can use that to figure out how much your H plus concentration went up by. You can figure out your C2H3O2 minus. You can figure out how much your acetic acid concentration went down by, and then you'll have all of your equilibrium values here. Once you have that, then you can just use the formula Ka equals, and then use the equilibrium there to figure out what your Ka or Kb is based on your experimental pH at the beginning. Okay, then you can compare that to the accepted. Now the percent ionization, all you have to do to find the percent ionization is basically, once you find this H plus number at equilibrium here, whatever this is, you just take that number divided by 0.1 times 100, and that will give you percent ionization. Okay, so that's kind of tricky right there. Let's see here. So then, the in-lab discussion questions. I like those discussion questions. I think what I want to do is kind of wait and put those at the end. You're going to have a lot of post-lab questions here, okay? So, again, your claim evidence section is going to be, here's what we measured our Ka or Kb for our weak acid to be. Here's the percent error, and that's all you really have to put in that section. I guess the comparison, the percent error, can go in your comparison section, okay, which is the next section. So the only other thing that needs to go in your claims and evidence, let's see, data collection and computation. Complete the data tables you've prepared, draw titration curves, determine the percent error, Ka or Kb, if appropriate. Now again, if your procedure didn't require you to use a weak acid or a weak base, then you don't have to worry about that part. But I think most of you did use a weak acid or weak base at some point. Pool data with other groups and compare titration curves. You're not going to be able to do that, so don't worry about doing this little section right here. Okay. I guess you do have till Tuesday, but we're not going to take time for that on Monday. Okay, so argumentation and documentation. Answer the following questions after you've completed your graphs and calculations. How did the process and titration curves drawn vary if the acids and bases are weak or strong? Okay, these all kind of look like post-lab questions to me. Alright, so the only other thing that you need to put into your claims and evidence section is answer the question your group is investigating. Okay, so whatever this question was that I gave you in the pre-lab, right here, whichever one of these 7 I gave you, in the claims and evidence section you need to also answer that question. Okay, so again, just to be very clear here, beginning question, background information, I think we're good on that because we already talked about that. The procedure, you're going to have your practice procedure, data, and graph. You're going to have your actual procedure that you wrote to answer your question. Make sure you note for me somewhere in there what the question is. You're going to discuss quickly lab safety. That's easy. You're going to record all your observations and measurements on your data. That's going to include your 3 titration curves. That's going to include your labeling of your titration curves. Okay, and I think that's pretty much it for observations and measurements. Then for the claims and evidence section, you're going to write down according to your lab what the Ka for the weak acid or weak base that you used is, and you may have more than one. You may have to calculate a weak acid and a weak base, Ka and a Kb, but use the procedure that I showed you here, and then your percent ionization. Okay, so that's 2 of the things you have to do for claims and evidence: Ka/Kb and percent ionization. The other thing you put in your claim/evidence is the answer to your question. Alright, whatever your question was, hopefully your data was able to give you a good answer to that question, so you'd make the claim and evidence there. That's really the most important part of the claims and evidence. The comparison, all I want you to do for the comparison is do the percent error of your calculated Ka or Kb, compare that to the accepted value. Okay, because again, we're not necessarily comparing to one another, because you all answered different questions, so I think the comparison there would be a little bit difficult. Plus, we're not really going to have time in class to do it. Okay? So that's all you need for the comparison section. Now for the ideas changed section, let me erase a little bit of this here. Wish there was a faster way to erase this, but for the ideas changed section, what I want you to do is basically answer all of the post-lab questions. Okay? This is going to take you a little while because there's a lot of questions here. There are some in-lab discussion questions. Okay? Right here. I want you to actually answer those in-lab discussion questions as part of the ideas, how did your ideas change section. Okay? So you've got that. Then you're going to look at the argumentation and documentation section. There's 5 questions here. I want you to answer those. Okay? Then in the post-lab assessment, there are 8 questions that I want you to answer. Okay? And if you're not completely worn out after doing all of that, and you really feel like you would like some bonus points on this particular lab, you can answer the challenge question. Okay? The challenge question will be 4 bonus points. And again, all of those questions will go in the ideas, how did my ideas change section. Okay? So hopefully that all makes sense. I know that it's difficult sometimes to fit these particular labs into our mold. So I'm sorry about that, but hopefully you'll be able to write it up correctly. And you've got until Tuesday, so if you have some questions for me on Monday, then you can ask those questions then. Okay? Alright, we will see you in class probably tomorrow. I don't know, it doesn't look like the weather's doing anything, so I think we'll be there tomorrow. So, we'll see you then.